So here we've got a square, we've got private data, and in main, creating a square object, and then we're saying side is assigned 10. What can be done to make this code compile and run? And I think the problem there is that that's our problem. We're trying to access an instance variable from within a static method. You can't do that, okay, because there's no this reference. But we have a reference, but we're just not using it. So we should say sq.side. Replace line 6 with sq.side is assigned 10. Now remember that private members of a class are accessible from the same class. The main method is within square, and that is why you can access the side field of square from this method. Okay, so that's just something worth noting. Okay, that's a private data item there. And I'm actually only able to say sq.side because I'm still inside the class. Once you go outside the class, that's not going to work. Okay?
So as you can see here, in the square class, I have a private double side, and in the main method in the class square, I can create an instance of square and then use that reference to access the private instance variable. That's on line 10. But that only works within square. If you look at the same code in the main method in circle, which I create on line 15, a square reference, and then on line 16, I try to refer to side using that reference, it does not work. Okay, that is a private instance variable inside the class square and is only available within the curly brackets, which start on line 5 and go as far as line 12. In other words, the class square.
Which of the following statements are acceptable? We have to select 4. Okay, object O is assigned new java.io.file a.text. Assume that java.io.file is a valid class with a constructor that takes a string. Yes, that's okay. We are upcasting to the base type. Every file is an object. Everything is an object at the end of the day. So that's okay. Boolean bool is assigned false. Now, that's okay. We're taking the primitive and we're boxing it as a Boolean. Okay, that's what's happening there. So it's auto boxing, or boxing as it's called. Char ch is assigned 10. That is okay because 10, which is an int, fits into a char. Now we're going to talk a little bit more about that in this section, because that is an int. And an int takes 4 bytes, a char takes 2, so what's going on? Should you not need a cast? No, there's particular rules for particular types, and we'll talk about that, okay? Thread T is assigned new runnable. No, that's not correct. This is correct. It's the other way around, and we'll talk about that now. Runnable or is assigned new thread. Now, threading and runnables are in the OCP area, but they have them in this, so we'll talk about them. Runnable is an interface. So you can always say interface, whatever the reference is assigned new, and then you specify the class that implements the interface. So I want to talk about that. So this is it. In the comment, interface I_ref. So this would be interface type, if you like. Interface type I is assigned new class that implements the interface. So that's our runnable, which is the interface type. My reference is R is assigned new thread. Thread is the class that implements the interface. You cannot instantiate or create an interface object like that. Okay, we know that. There's my type, but I can't new an interface because there's no code in it at all. But why does this work then? And that's what Enthuware, because if I go back to Enthuware, that's in there. And if you were to look at it, I want to explain it. This piece of code here is why I have this. So actually what you're doing here is what's known as anonymous inner class. And this will help when we go talking about lambda expressions. Okay, so runnable R2 is assigned new runnable. Now, if we take it from just there, okay, that's what's failing up here. Can't do that. But what you can do with, and this is particular syntax, is you can slip in a class in a set of curly brackets. This is the anonymous inner class because you're not giving it a name. It's not going to have a name. So when I put that in, there's the semicolon that's at the very end of the statement, like there. That's what that semicolon is. This is the outside of your class, like here. There's my class. The curly brackets to the curly brackets. There's same thing. That's a class definition that's in here. And all we're putting in is one method called run, and it doesn't do anything. We're overriding the method run, which is what is in the runnable interface. Runnable interface is only one method, public void run. And we're specifying a class, which has no name in it, that overrides that run, that provides the run. So now you're signing the contract for the interface. You're satisfying the compiler saying, yeah, okay, I have to put in something here, some class that implements the interface. Well, this is it. There's no name on it. There's the implementation of the method it's supposed to put in, and that's it. That's your anonymous inner class. All right? So that was in that particular one. That's why I wanted to talk about that. Which of the following can be valid declarations of an integer variable? Well, that's garbage anyway. That's C. So that's not a valid keyword at all. Final int x is assigned 10. Yes, that's fine. Note that that's known as a compile time constant. And we'll be talking about that now. Public int x, well, that's a capital I. That's a problem there. There's another one with a capital I. No, we don't want that either. Static int x is assigned 10. Yeah, that's fine as well. Okay, that's good. Given the following class, which of the given blocks can be inserted at line 1 without errors? Okay, now we have a private static int loop. That's a static. That is also a static final. So that's final. Can't be changed now. It's been initialized. And that's an instance variable. So remember that going from an instance to a static is okay. IS. Instance to static is okay, but not the other way around. Okay. So I'm inside a static block here. How do I know it's a static block? It's a block of code with the keyword static in front of it. If you've just got a block of code and no keyword in front of it, that is an instance block. Static block will have the static keyword in it. So all we're doing here is outputting a simple message. Well, that's okay. No problem with that. What about the next one? In the static block, we're saying loop is assigned 1. Well, what is loop? Loop is a static. Static to static is okay. It's not a final, so yeah, that's okay. The next one is static loop is assigned whatever's in loop, an add-on interval. Yeah, we're only changing loop. Loop is not a final, so that's okay. Static interval is assigned 10. No, that's a final, and the capital letters should highlight that. So you can't change it. It's a constant because it's final. The next one is an instance block. Now, an instance block, you can access instance variables and static variables. What are we saying here? Flag is assigned true. Well, that's an instance variable, so no problem there. Loop is assigned 0. Loop is a static, but it's an instance block, so we can go to access static variables. Yeah, that one's there. Okay. Okay, so the following code snippet will print 4, true or false. Okay, so there'll be a few things here. I want to look at a NetBeans program as well. So the first thing to realize here is that the round brackets are just there to get it to compile. Not there for order of precedence. Okay, just want to get it to compile. If you leave out the round brackets, it doesn't compile. So what we're saying here is when you have a binary operation like this, the left one is evaluated first, and then you evaluate the right one. Goes left to right. So I1, which is set to 1, is added to, I2 is assigned I3, so I2 is replaced with the value of I3, which is 3 goes in there. So now you're adding 1 with 3. So that's 4. 1 plus 3 is 4, which is correct. But let's look at it in a little more detail. I didn't talk about question 4. All right, I wanted to talk a bit more about question 4. I'll come back to question 4. Question 5 is one we're just on. So just to, okay. This was what it was. And there's another one, so that's why I'm getting that error. So if I make that I5. So just to show you, if you get rid of the round brackets, it won't compile. So you put it in and you get 4. Now, according to the Java language specification, the left-hand operand of a binary operator appears to be fully evaluated before any part of the right-hand operand is evaluated. Okay. So in this expression here, the plus is the binary operator. That's an operand, I1, and this is an operand as well. This is one now that will be a little trickier because you're changing I1. So then you might be wondering, what's I1 now? Is it the original value, 1, or is it 9? Yeah, so that's when you have to remember this. So it's that one, it's 1 plus 9. Then it changes it afterwards to become 10. Whereas the order of precedence, as you know, 3 plus 2 by, well, that's higher priority, so 2 by 3 is 6 plus 3. But if you've in brackets around here, now you're changing it. So it's 3 plus 2 is 5 multiplied by 3. So let me go back to question 4.
This is about the static variables versus the instance variables.
So this is to highlight and reaffirm so that you make no mistake on it. IS, instance to static is okay. Instance to static is okay. So I've got a class variable here, which is static. I've got an instance var, which is non-static. I'm inside in main, which is a static method. I can access the static variable, that's as you would expect. I can access the static method, which I've coded down here, it's static. No problem, you'd expect that. Static should be able to access anything static. I cannot access the instance variable, and I cannot access the instance method because I've nulled this reference. Okay? If I wanted to access them, then you create an instance, which is the name of the class here. That will enable me to access the instance method, and I can get access to the instance var. If I'm in an instance method, I can access the instance var, as you would expect. I can call another instance method if I want. And I can access the class variable. I can call the static method. This.classVar is the same as classVar, so I just put that in as well. Is that okay? So that's covering those kind of concepts, instance to static. Okay, let's go back and look at number 6, which is 2.14.21. This particular one, you have a static variable here called %. Now, instance variables and class variables, as you know, they're declared inside the scope of the class and not inside a local method. They are given default values if you don't assign them to anything. So % is going to be assigned a default value depending on its type. Double, % is going to get 0.0. An int, it's going to get 0. Char, it's going to get 0. String will get null. Okay, Boolean, false. Local variables must be initialized by you. They do not get default values. So here we have 3 local variables here. Now, if % is less than 10, okay, then they will get initial values. However, this is just a class variable. It is not a compile time constant. It's not final, in other words. So therefore, even though at runtime, that'll get 0. The compiler has no idea. It's going to say, oh, hang on a second, that could be false. Therefore, when you go to try and do something down here with these variables, they're uninitialized as far as the compiler is concerned. And that's going to give you an error. That's going to give you an error then. Your local variables must be initialized before you use them. Now at runtime, yes, that's going to be set to 0, and therefore 0 is less than 10. We know that it's going to be initialized. The compiler, no, that's not the way it works. But if I had made that a compile time constant, then what would happen? It knows at compile time what the value is, and then it can change. You can plug in the value there instead of that variable. So let's look at something like that. This is the first one. This is the error that you get. Variable coupon might not have been initialized. Variable offset might not have been initialized. Variable base might not have been initialized. Okay, that's the error you get. Now, here I make this to be a compile time constant. So what did I have here? Static double. Now I've gone and I've made it final. Static double. I've initialized it to 0 as well. Okay. Now, because I've made that change there, it compiles. See, the error is gone. And that's because the compiler says, okay, that's a compile time constant. That's not going to change its value. So then in effect, that's what the compiler puts in. Instead of if % is less than 10, it'll be if 0, because it knows what % is, and it knows it'll never be changing. So the compiler can directly put in the compile time constant there. And now it knows they will always have a value when it runs this program. Is that okay? That's what that means there. Okay, let's go back and do another one.
Just on that one there, Sean, are you not
Sure.
also trying to get, you're in a static method there, you're not also trying to get instant variables, offset and base? Are they not instance variables? Or is it?
What's happened here is that when a method, very good question, when a method sees a variable, it checks for the variable in its current scope, and that's the first place it looks. So the current scope for that method is there.
Oh, okay, yeah.
And there's one there.
Oh, sorry, yeah, gotcha.
Yeah, and there's an offset there, and there's a base there, and they are hiding. I'll put that in there because that's a good point. Hiding the coupon, offset, and base. There was no, it's just offset and base. Yeah, hiding the instance variables. So we're hiding the offset, hiding the variables that are up here. Okay, because of the same name, offset and base. Yeah. So it looks there, it sees these guys, and then if it didn't find them there, it'd check the outer scope after that, which would be there, and then it would start using these guys. That's how it works. Okey-doke. Okay, so the next one is this one. Consider the following lines of code. Integer I is assigned new integer 42. Long L is assigned new long 42. Double D is assigned new double 42.0. Which of the following options are valid code fragments? Now, this is not going to even compile because the compiler figures out, hang on, that's a reference to an integer. That's a reference to a long. They can never be equal. Okay? Same with the ln equivalent. You're using the equivalent here. Okay? So that leaves us with the last three. Which of the following are valid? Remember, it's looking for valid. Will they compile? I dot equals D, yes, yes, and yes. Those three are valid. All three of them will return false though. Because the first thing, this is from integer, and they all have the same. That's the double equals, and that's the long equals. The logic for each of those equals method is return true if and only if the argument is not null and, in this case, is an integer, but it's not, so it's false. Or in this second last one, that needs to be a double. And then that last one, the long version, that would have to be a long. Okay? And then it will compare the values after that. But if the types are different, it'll come back false. But here, the equivalence knows, well, hang on a second, you're talking about I, which is a reference to an integer. Is that equivalent to the long? No, can't possibly be. Okay, here's main, parseInt args 1, and then output args with that index of I. Okay, so there's the JVM, there's the name of the class, args 0 and args 1. So integer.parseInt args 1, that means I becomes 2. And then we output args with an index of 2. But we've got an args with an index of 0 and 1 only. So that's an array index out of bounds for that reason. Yeah? Now, which of the following declarations are valid? That is incorrect because 1.0 is a double. You need an F there afterwards for that to be okay. Same here, that's a double. It's 430.0. So you can't go double into a float. Float F is assigned -1. Yes, you can go from an int into a float. That's an int as well. Integers can be represented, obviously in decimal, but also in hexadecimal, in octal, and in binary. Okay, binary would begin with 0b, capital or lowercase, doesn't matter. Octal will begin with 0. Okay, so that's why you don't represent your integer literals. Don't start saying, well, this is, 65. You don't say 065 because that'll be an octal number then instead of a decimal number. You just say 65. That's okay. And that's okay. The int can be put in. Now, we want to talk a little bit about this as well. So let's evaluate that. Although the values in the options 1 or 2 are compile time constants, so they're compile time constants because they're literals. They're literal numbers which are never going to change. So they're compile time constants as well. They can fit into a float. Implicit narrowing does not happen. So you're trying to go from a double into a float. Why won't it do it? Because implicit narrowing is permitted only among byte, char, short, and int. Byte, char, short, and int. Narrowing, where you're going to lose data. These are the integral types, the integer types, the ones that have no decimals, no floating point values. Byte, char, short, and int, they're all whole numbers. They're the ones that allow the implicit narrowing. So this is number 10. Let's have a look at that. Okay. So implicit narrowing applies only to compile time constants among the byte, the char, the short, and the int. A compile time constant variable, now I'm talking about a variable here as opposed to 33, something like that. That's a literal, because literal values are automatically compile time constants. Talking about variables here. How do you know what's a compile time constant? It must be final. It must be a primitive or a string. What's a primitive? It's your int, your char, your double, lowercase letters. And it must be initialized at the point of declaration. Literal values are automatically compile time constants naturally because they won't be changing. So here I'm representing an int. That's an int. Okay. So your ints, if I write in here, ints can be represented as decimal, which is nice and handy. Octal, so they begin with 0. Hex begin with 0x, and binary begins with 0b. And it's capital or lowercase, doesn't matter, okay? Same for all of them. So 0 hex 61 is an int with a value of 97, which is the lowercase a. 97 fits into a char. That's the range of the char, 0 to 65535. As hex 61 is a literal, it is naturally a compile time constant, as it will never change. Therefore, the int is implicitly narrowed to a char, because that's 4 bytes going into 2. Okay? I can't put a double into a float, but I can do this when it's an int and a char. Doing the same thing into a short, putting it straight into an int, and put it into a byte as well. Okay? When I output them, note I get the actual value, except for the char, I'll get the letter, the character. Now, the value must be in range. If I have a hexadecimal, 123, that's 291 in decimal. And that's outside the range of a byte, which is -128 to +127. And there's the proof, putting -128 in there. It'll only work for compile time constants. So here, x is not declared as final, and therefore x here is not a compile time constant. If I make it final, then the error assigning x into y2 goes away. So here's a byte, right? Byte y is assigned 6. Simple. Okay? 6 is a small number. Okay? But look at this. I'm putting 6 into my int. And then I go along and I try to put my x, which has a small little number, into my byte, and it won't work. That's a compiler error. Okay? X is not a compile time constant. That's why. If I make that final, see, that error goes away now. So there have to be compile time constants for that narrowing to work. And it only works between the small the integral types, the char, the short, the int, and the byte. Okay, and that's when it really kind of wrecks your head when you see, whoa, that's only a small int though. It's only got 6, but that doesn't matter. It could be a number that could be way outside the range of the byte. Okay, which leads me to think if I go and make it a constant, and let's go 6, 1, 2. Now we've got a problem. Outside the range of the byte, -128 to +127 is outside the range. But when you're inside the range, it's okay. Now you can cast it. That's what, if it's not a final, this will work. Say, okay, that's an int variable. I can cast it down and it'll be fine. So that's just a few little pointers on that. Tricky little things, okay? Tricky little things that. So here's square, private, double side, and test class. Which of the following statements will set the side of square object refer to my square to 20? Okay, that's pretty straightforward. You have side is private, but you've got a public method here called setSide, which will enable you to do it. So you're inside another class, can't directly access it because it's private. So it's the mysquare.setSide is set to 20, setting it to 20. Okay, I'll evaluate that, make sure it's okay. Yeah. What happens when you try to compile and run the following program? Okay, so here we have a byte b is assigned -128. Is that within range? Yes, it is. Int I is assigned b. Can I do that? Yes, because you're going from a byte up to, you're upcasting in a sense, to an int, to 1 byte going into 4 bytes, no problem. You're going back the other way now. You're going from here, you're going from a 4 bytes into a 1 byte. So you need to downcast it because it's not final. That's not a final here or there. So, but then when you output it, well, that shouldn't be a problem. There's nothing that's going to fail in you there. And an int can take a negative value, as we know, that's a signed value as well. So you should get -128 and -128 for the two of them. Yeah. The compiler will refuse to compile because -128 is not outside the legal range. No, it's within. The range of a byte is -128 to +127. So 2.1319. Nice handy one. Given that code snippet, what can XXX be? And it's a double. Has to be. Because we're not, no wrapper classes here. Wrapper would be valid, the capital D for double, if I evaluate it here. It'll say that in the answer. That otherwise, double is also valid, but that isn't one of the options. It's only the primitive one that it's mentioning here. So therefore, that is okay. And here we have identified the correct statements about this code. That's incorrect. You can use underscores, you can't use commas. So line 1 is a problem. Switch on value, that's okay, but that's only for readability purposes. So that's case 1,000,000. And you cannot have duplicate cases because Java won't know which one to select. And that's exactly the same thing here. So that's a problem as well. So line 1 is a problem and line 3. Compilation fails on the two of them for those reasons. Yep. So this particular one, okay, and we'll finish with this one. I want to draw that on a board, and I've got a picture as well. Okay, so let's go and to the board. Okay. So inside in main, we're creating a new test class here on that line 3. That's okay. And then we're using the test class reference to call the instance method get my class object there. So the my class is an instance method, so we need a reference. And then we go in here and we create on line 1, a my class is assigned new my class. Okay, so we have main, and then we have get my class object. Now, the get my class object is creating a my class reference MC, which is referring to this object of type my class. And then it just returns that reference, and that reference comes back into this X in main. So you end up with X in main referring to whatever was in this my class. Okay, so that's what line 4 is doing. Between line 2, where you return MC, that goes into the method returns that into X there. And then this goes out of scope, gone. And then we come along and we say, okay, on line 6, we say, it's hard to read it there, X is assigned new my class. So X is no longer pointing to there, and it's pointing to a new my class. And that was on line 6 that did that. After what line is the my class object created at line 1? Will it be eligible for garbage collection? So this was the one that was at line 1 over here. Inside the method here. Okay. And when is it eligible for garbage collection? After line 6 there. When we did the X. When we did this bit here, reassigned X. So line 1 created this one. We returned the reference into X over here in main. That's fine. This reference has gone here, but we still had this reference here pointed to my class object. But when we said on line 6, X is assigned a new my class, then there was no reference to this object anymore now. X is referring down here. And therefore, that is now eligible for garbage collection.
Hi everyone, the first question that I want to start with is 2.1272 from Enthuware. Which of these are not legal declarations within a class? So we have to select one. Static int SA, that's absolutely fine. Final object array obj_r is assigned curly brackets null semicolon. That's absolutely fine. It's an array of objects, that's the reference. It's final, which means you just can't change what that's looking at, and you're initializing the only reference that's in there to null. Abstract int t, no, that's incorrect. Abstract is for methods like this one here. No curly brackets, that's fine. It's an abstract method, it doesn't have an implementation. Final static private double pi is assigned, and there's a double value, so that's fine. It's the abstract int t is the problem, and that's correct. The next one is 2.1118. Which of the changes given in options can be done independent of each other to let the following code compile and run without errors when its generate report method is called? So here you've got a class, you have a string s is assigned green mile, then you have a method, generate report, and there you have a string and it's local. So that needs to be initialized before we use it. If n is greater than 0, local is assigned good. System.print line S1 and then there's local. So there's the line numbers that are identified down here. Please select two options. Insert after line 3 else local is assigned bad. So after line 2 we can put in the else local is assigned bad. Let's come back to that one. Insert after line 2 if n is less than or equal to 0, local is assigned bad. And that's why I wanted to talk about this one in relation to this one. If n is less than or equal to 0, okay, if n is negative, we're going to set local to be bad. That's after line 2. So it's a separate if statement. And that's a problem. Okay? Because Java doesn't realize that, whereas the else is an integrated one. So it realizes that if n is greater than 0, local will get initialized, else or otherwise local is set to something else. So that one if statement with an else will ensure that local will get initialized. So that's why that's correct, and that's why that's wrong, because it's a separate if statement. Yes, we know if n is greater than 0 or if n is less than or equal to 0, local will get set, but that's not the way the compiler works. Move line 1 and place it after line 0. Here is line 1. Place it after line 0, which means it now becomes an instance variable, which means it gets initialized for you by default. Local variables do not, but instance variables or static variables will be initialized. It's a string, so it will be initialized to null by default. Change line 1 to final string local is assigned Rocky. Change line 1 to that. Okay. That'd be fine, except it's final now, and you're going to have a problem changing it anywhere else. The program already is without any errors. No, it does have errors. So there we go, and that's correct.
This particular one looks nice and easy. The only problem here is that it's the character. So they're all static variables in here. And we're going to refer to them from in main directly. So that's a static context, no problem referring to statics. Okay, so what's the output? Okay, now these will, if they're instance variables or class variables up here in the declared in the space, if you like, outside of all the methods, that's where your instance variables and your class variables go. Now they don't have to be above the methods, it could be down here just so long as they're outside the scope of any method, and that's the scope of that method there, and there's the closing curly bracket. So you could have them down there between the two curly brackets there. So they'll be initialized to particular values for you. That will be initialized to binary 0. That'll be initialized essentially binary 0 as well. So that's 0. It's a small number. That's what a character is. That's 0.0, okay? And that's false for bool. So when we print it out, okay, then there's no F going to appear. So it's going to be 0.0. So you can forget that one, you can forget that one and that one. That's going to be 0.0. Then you've got a space. Let's look down here. This is the easier one. This is false, okay? So now you're looking at 0.0 and false. And what you've got to decide is what is the character going to print out on 0. Now, if the number is small, 0 to 32, it'll just print out a white space character. Now, white space character could be a space, it could be a line feed, it could be carriage return. Like for example, 8 is the backspace. So if you look up the ASCII table, you'll see these values, okay? 9 is horizontal tab, and 10 is line feed, which brings you on to the next line. Whereas if you get a number a little bigger, like 97, that's lowercase a in ASCII. So let's look at that in NetBeans. It's the exact same variables are up here, and then we're outputting it down here. But when I run it, you'll notice that I've got, I'll do right arrow 3 times here. 1, 2, 3. Second time it didn't move. And that's what null does. At least it's a white space. It's not some funny looking character. But you can see all these other funny characters down here. So this is just a by the way. ASCII values 8 is a backspace. 9 is a horizontal tab. 10 is the line feed, which brings you on to the next line. So what I've done here is I've set up some characters. HT is the horizontal tab, set to 9. Backspace is 8. Line feed is 10. And then I horizontal tab, and then I append on ABC. So you can see that there's a tab there, bringing me to ABC. And then I append on the backspace, which basically deletes the C. Then I do the line feed, which is like the old typewriters, brings you down onto the next line there, and then DEF. So it kind of like, this is what these hidden characters do. Then if I go 97, if you look up the ASCII table, you see all of these, that's lowercase a, and 48 is 0. So I say lowercase a is set to 97, and the variable 0 is set to 48. So I output lowercase a, then I append on a tab, that's the escape sequence, and then I append on 0. So there's a, and then there's another, well, I actually use spaces, I think, on this one. It'd be tab, and then 0. So there'd be, should be a tab on this one here. Yeah, there. So note that it comes up 48 in that variable comes up as 0. So how do I get 48? Well, you cast it to an int and you'll get your 48. Your lowercase a, cast it to an int, you'll get your 97. So it'll just come up with the encoding. It takes that number and it encodes it into something to display, a character. All right? So that's what's going to happen there. The first 32 characters, 0 to 31, are special characters such as null, carriage return, horizontal tab, vertical tab, form feed, and the representations depends on the machine's character encoding. In other words, I have this character, this number, how do I display it? Okay, suffice to say that the first 32 characters are tricky. So basically I just started a loop, character 0 up to 31 including, and I output it. And you can see that's what I started getting, this kind of stuff. So in the unlikely event you get a question like that, that's just a program to kind of show you what that's all about. Okay. So what's going to be output in that situation? Well, underscores is just for readability, just for us, for readability. That's going to be 13. That's going to be 13. And then there's your float, and note there F will not appear in the output. So the answer is that one there. No F at the bottom. No F at the end of it. That's what you just need to remember with floats. Now that underscore there, as you know, it can't go at the very start or at the very end or either side of the decimal point. Okay, so remember that with the underscores.